In this third and final video on the UK water sector regulation experience, we'll look at how Ofwat, and water regulation more generally, deals with innovation for future challenges. I said in the previous video that I believe this is an important area that the regulatory framework here has somewhat overlooked. This slide shows two simplified descriptions about how regulation and innovation can act in any particular industry sector, like the England and Wales privatised water industry. One view is that regulations prescribe too much detail about what an industry sector can and cannot do. Companies are therefore constrained or have limited possibilities for innovative behaviour. In this case, the view is that regulations should be minimised or removed entirely to promote more innovation. This is the deregulation stance. An opposing view is the revisionist stance. This takes the view that regulations can in fact set future targets for companies to achieve that would not otherwise emerge from normal market pressures. Often the targets in these regulations would not be fully achievable with present approaches and technologies. Therefore, actors within the global economy will choose to innovate to make such new performance levels possible. This means that regulation can actually spur innovation. However, it's important for regulations like this to allow sufficient time for innovations to be developed and brought to market. One measure of innovation activity by firms is their spending on research and development, or R&D. I should say this is not a perfect or complete measure of innovation activity. It somewhat assumes that innovation is a linear process that starts in the lab and then works its way into products and processes that are then marketed by a particular company. However, things are rarely this simple, but R&D spend data is available for the England and Wales water companies, whereas more nuanced indicators of their innovation activity are not. So we'll work with what we have. This slide shows the annual R&D spending totaled for all 10 of the major England and Wales privatised water and sewerage companies. The spending levels are shown here in constant 2009 prices, in millions of pounds sterling. It's interesting to note that after the water privatisation in 1989, R&D spending quickly almost doubled. That would support a view that privatising a sector gives it more freedom to innovate than if it had remained in the public sector. It's a complicated picture, of course, and one that varies from water company to water company, but it is true, at least from my research, that the water companies did experiment with all kinds of innovative activities during this early post-privatisation period. Some water companies started or enhanced their existing R&D laboratories. Some water companies bought smaller technology companies to try and develop new products or processes. Some water companies even merged with non-water utility companies to experiment with different forms of organisational innovation. These activities then hit a kind of plateau, according to these data at least, around 1999-2000. R&D spending then declined quite dramatically, eventually falling to around half the level that we'd originally seen at privatisation back in 1989. Incidentally, this coincided with the increasing complexity of Ofwat's regulation. Was this dip in this proxy measure of innovation activity caused by these regulation changes, or other factors? I'm not aware of any systematic, quantitative research that could give us an answer to this. I have, however, done some qualitative research on this topic, so I'll give my views on that here. You'll recall that 1999-2000 was when a decision was made, as we mentioned in our previous video, to cut back strongly on the earlier RPI-X price cap regulation settlement that the water sector had been getting. A somewhat challenging determination was made at the 1999 price review, and it cut the previous settlement by around 10% at a stroke. The then Ofwat Director General, Sir Ian Byatt, led this change. What seems to have happened is that the water companies responded to this increased regulatory uncertainty by, among other things, cutting back on their R&D spending. In the broader scheme of things, this is quite a small cost reduction for them to make. There were many other activities that perhaps they could have cut to save money. My research, though, suggests that the decision to cut R&D spend was a signal of sorts about a new strategy that the water sector as a whole was taking. It was to cut back on R&D activity that could have longer-term, less certain outcomes, and to focus more on shorter-term priorities. This view is somewhat supported by the data in this slide. These data show subscriptions paid by the 10 main water companies to a collaborative research body representing the interests of the whole sector. The collaborative body is called UK Water Industry Research, or UKWIR. The 1999 price review again stands out here as a milestone. So not only did water companies cut back on their internal R&D spending, They also cut back on external R&D spending that was shared in collaboration with the other water companies. Once again, the amounts of money shown here, in constant 2009 price millions, are quite small. But I think they signal a change of strategic intent. What we see here is not a revisionist stance on the interaction between regulation and innovation. Regulation apparently tightening was not met with an increase in R&D spending to try and develop more innovative ways to do the same or to do more with a lower price settlement, at least seen from the perspective of this proxy measure of R&D spend for innovation activity. I'm going to use a short example here to stress why the reduction in R&D spending, as a possible reaction to regulation at any point in time, is an important thing to think about. You may have seen the blue plastic water pipes that are commonly used around the world for clean water supply networks. Some are shown in this photo. Small plastic pellets are melted down, then extruded into lengths of pipe in various very large factories around the world. The colour is an added pigment. It's not critical to the properties of the pipe. I've seen the manufacturing process firsthand, and it's very impressive. It's automated and uses surprisingly few staff. These blue, high-density polyethylene or HDPE plastic pipes replace the previous pipe material that was commonly used in the UK. That was cast iron pipes. This photo shows a cast iron water mains pipe being installed in London in 1925. It's from the Thames Water Archive, which they've permitted us to use here. Obviously, plastic pipes were not available at this time. They did not yet exist. But iron pipes also have several major drawbacks when used for water supply. The main one is that they of course rust in contact with water. This corrosion can build up to such an extent that it practically fills the interior of an iron pipe. It reduces water pressure through the pipes, meaning that the pipes eventually need to be replaced. Also, if the direction of flow needs to be reversed in an iron pipe, say due to maintenance nearby, then the rust can come off the interior of the pipe and contaminate the water supply. By comparison, plastic pipes have a range of advantages. They do not rust. They can be extruded into very long lengths and then coiled up for easier transportation and storage. They're flexible and so are less likely to burst or leak under pressure. And if the joints between plastic pipes are made correctly, they can last long periods of time, at least around 50 years according to sources that I've seen. But how did plastic pipes come to replace most of the cast iron water mains in the UK? And are the plastic pipes we see nowadays in the UK the same ones that were originally used to replace the cast iron pipes? And has anything changed in the way that they are used or installed? This slide shows a timeline of the adoption of plastic pipes by the England and Wales water industry from the 1960s onwards, from research that I've done. On the left-hand side are rough markers of stages in the adoption process. They go from the start of the innovation, through R&D activity and demonstration, to pre-commercial or trialling stages, to being established and in wide-scale use, then finally to being obsolete. Overall here we seem to see a 40 to 50 year time horizon for the adoption of plastic pipes as an innovative product for the mains supply of the water networks in the UK. We also see here that it's a bit of a non-linear process, with various trips back to the drawing board, as it were, for further stages of R&D, and for iterations in the design or properties of the material. The first leg we see here from the 1960s to becoming obsolete in the mid-1970s involved PVC plastic pipe. PVC plastic pipes became notorious for what is known as rapid crack propagation. That means if they cracked, the crack would spread at the speed of sound, causing entire lengths of pipe to fail in almost an instant. The second leg we see here from the early 1980s to the early 1990s was the development of medium-density polyethylene or MDPE pipe. A third leg from the early 1990s led to the development of high-density polyethylene plastic pipe or HDPE, to give flexibility of use in differing applications. Other new approaches that were developed included dragging a new pipe into installation whilst bursting away the old pipe that lay in its path. Initial problems with joint failures on plastic pipes, say due to dirt on-site contaminating the joint during installation, were also addressed with innovations in peelable pipes. Here the blue outer layer could be peeled off on-site to reveal a fresh, clean surface for the welding. In so doing, the costs were also reduced by only having the outer layer coloured blue. The remainder of the pipe was left white or unpigmented. The blue colour was still useful, as the colours of pipes are used as markers for their intended purpose. For instance, blue for clean water, black for sewers, yellow for gas supply, and so forth. Cold welding techniques were also developed and used. And barrier plastic pipes with a layer of aluminium in the middle of a sandwich between plastic layers were developed to allow clean water supply underneath contaminated land, to avoid the risk of contaminants leaching through the plastic and into the water supply pipe. In short, the move to plastic pipes from cast iron led to a whole series of innovations following on from the original adoption of a new pipe material that was originally from the gas sector, in fact. And it brought a whole host of parallel innovations in the areas of installing pipes. The move away from cast iron pipes was in part motivated by new environmental regulations requiring higher drinking water quality standards than could be met with corroding old cast iron pipes. So we have an individual case description here that economic regulation can be a barrier to innovation, and the plastic pipe case is an example where environmental regulation required higher standards for drinking water than could be met with cast iron pipes. So in this case, regulation did enable innovation. In my own research, I've gathered further qualitative evidence that EU environmental regulations may also have spurred technology companies supplying the water sector to take a long-term view and try to be the first to market with innovations that allow the water companies to comply with future environmental targets. So now we have one example that supports the deregulation view of regulation as inhibiting innovation, and one example that supports the revisionist view that regulation can foster innovation. Personally, I'm more persuaded by the revisionist view. But does regulation spur innovation in developing countries? There has been very little research on this, but it's an important policy-relevant question. Another important implication here, though, is that innovations in the water sector can take a very long time, perhaps many decades for something as widely used as plastic water mains pipes. And R&D, in one form or another, has been necessary at various points along the way in the plastic pipe story, stretching back many decades. Reducing spending on this part of the innovation pipeline, as it were, could have unforeseen consequences for the ability of the water sector to develop innovations to address future challenges. To close out this video, I'd like to look at the institution of regulation itself as a source of innovation in its own right. I've heard some stakeholders in the England and Wales privatised water sector ask, what is Ofwat's end game for its economic regulation? To me, this seems an invalid question. For the sector to be dynamic, there is no end game. It's rather a matter of continuous innovation for continuous improvement. This slide from Ofwat data shows what might in fact happen if Ofwat did take the endgame view. That is, if it kept its regulatory tools the same forever and did not innovate in its own approach. In this slide, you can see Ofwat's view on the percentage cost efficiency gains from its comparative economic regulation approach in two successive price review periods. AMP or AMP here stands for Asset Management Plan. This is a water company investment period, and it roughly overlaps with the 5-year price review periods we've already seen. In this slide there's AMP3, which lasts from 2000 to 2005, and AMP4, which goes from 2005 to 2010. You can see here that both capital or CapEx and operational or OpEx expenditure efficiency gains declined from the 2000 to 2005 to the 2005 to 2010 period, or from AMP3 to AMP4. In other words, Ofwat saw that using the same approach was bringing some kind of diminishing returns in terms of the efficiency gains over time. So should it innovate in its own regulatory tools to create new performance targets and possibilities for the water companies? I believe so. This slide shows my simplification of how I believe Ofwat saw the past and the possible future in terms of its role as economic regulator. The past has led to a capitally expensive, centralised water supply and wastewater treatment system that some have argued has been overly short-term in its outlook, and rather reactive to just what the regulator was stipulating. It did what it was told, but no more. The possible future would be a system that would be more resilient to a changing climate and changing population dynamics. It would be more sustainable in terms of water and energy resource use. And it would take on its own a longer-term view, so be more proactive about shaping its own destiny with less hand-holding, as it were, from the economic regulator. This slide shows some of the main future challenges such a system will have to face up to in Ofwat's view. There's a changing climate in the UK, with more possible droughts and floods. There's the challenging, perhaps increasingly volatile, global economic environment. There are changing customer preferences and expectations, and the expression of these in future environmental legislation, like the European Water Framework Directive. And there's population changes. Ofwat has been quite innovative, I feel, in mapping out what issues it thinks it can influence through its economic regulation, and those which it cannot. Around 2012 or 2013, Ofwat conducted an internal strategic exercise on this. I believe Ofwat doing so showed quite interesting and deliberate attempts to develop more regulatory capacity and foresight. For instance, Ofwat had a stated goal at the time of ensuring a fair deal for customers. In its strategic exercise, Ofwat believed it could directly influence water bills through the water price limits it sets, but it could not directly influence the wider issue of affordability. Affordability is a broader matter affected by government social policy and wider economic factors, clearly beyond Ofwat's direct control. To summarise these 3 videos on the UK water regulation experience, we have to start by being clear that what we see in the England and Wales case is 2 distinct but overlapping processes of institutional change. First, there was the full divestiture privatisation of the England and Wales water industry. Second, there was the creation of a suite of new regulatory institutions, of which the economic regulator, that we've mainly focused on, Ofwat, was just one part. For most England and Wales stakeholders experiencing or working within this system, these 2 institutional change processes are quite difficult to separate out. It's hard to understand one in isolation from the other here. There have also been almost 3 decades in the case now to develop regulatory capacity, and there have been trials and errors and learning from apparent mistakes. The approaches taken to regulation have evolved over time, such as the drift away from a more simpler form of RPI-X price cap economic regulation. There's been some innovation, from the original advocacy of RPI-X by Littlechild to Ofwat's recently introduced Information and Assurance Framework, for instance, and ongoing attempts to introduce more competition into the system. And the whole UK regulatory enterprise has involved many world-class individuals, both managers and scholars. All of this, similar to our account of the UK water privatisation experiences, introduces a note of caution about trying to transfer the UK's water economic regulation experience to other parts of the world. A lot of what has happened has been local to England and Wales, and once again the UK is an outlier in terms of its particular water regulation approach, as it was with its water privatisation approach. Nevertheless, we think that, given this caution, there's still much that can be learnt from the UK's water regulation experience. Thanks for watching this video.